So you are going to use your prior knowledge about parallelograms, what you've already learned in prior grades, to decide whether these statements are true or false. We are starting a new unit today. The unit is called quadrilaterals. So we're shifting from three-sided figures, triangles, to four-sided figures, quadrilaterals. 1. What do you think? Are the opposite sides of parallelogram ABCD congruent? True. Very good. That is one of the properties of a parallelogram. Angle A is congruent to angle C. What do you think? Sure, true. Maybe you think, yes, it looks like it's true on the picture. The diagonals are congruent. The diagonals are congruent. We don't know this yet, but that one is absolutely false. AB is parallel to DC. True. Okay, so like we said, this name of this unit is called the quadrilateral unit. A quadrilateral is simply a polygon that has four sides. So some of the quadrilaterals, we name them, and some quadrilaterals are just going to be quadrilaterals because they're not going to have any special properties at all. Let's see if we know all of these quadrilaterals. What is the first one? It was in our warm-up. It is a parallelogram. The next one, right here, is a square. Can y'all see this? The next one is a rectangle. There's a big delay on this. The next one is a trapezoid. The next one is a rhombus. And the last one is a, do you know? It's actually called a kite. It's not called a diamond, it's called a kite. Actually, the shape that most people consider as a diamond, that one's a rhombus. Whereas the kite, we'll talk about later, not all the sides are congruent. But when you see something that's generally considered a diamond, it's usually really a rhombus. All right. You should have your family tree out with you, right in front of you, your family tree. It was on the calendar. That's what I'm going to refer to this as. We're going to focus the next 2 days on this side of your family tree. And we're going to zoom in first on parallelograms. So, pictures of parallelograms in the real world. We have them showing up in architecture all the time. That bus lift that lifts a bus up so you can work on the bottom, that's a parallelogram. This person, I guess, was really bored and folded their bag of chips into a parallelogram. And then this one's my favorite. It's a restaurant that juts out over the lake or the, I don't know if it's an ocean or lake or whatever, but it's in the shape of a parallelogram. So I thought that was really cool, really pretty. All right. There are 5 properties that a parallelogram has that we discuss. I showed all 5 properties in these pictures. Don't write them down in your notes yet, but go ahead and hypothesize what you think the 5 properties are looking at the pictures. Johan, you said, thank God, trig is over. But trig is going to be inside the quadrilateral unit a little bit, so just be careful. Don't forget about SOHCAHTOA. There you go, Chloe. Way to be positive. All right, what is this first one showing? What is the first property of a parallelogram? What do those arrows even mean? Edril, you rocked trig. That's true. What do those arrows mean? Not just parallel sides, but be more specific. Okay, so that is not showing that just sides are parallel. It's showing that the left is parallel to the right. It's showing that the top is parallel to the bottom. So that means opposite sides are parallel. So that's what that one means. What is the next property showing us? What do those symbols mean to us? Opposite sides are congruent. Very good. Okay, next thing. What do arcs mean on our picture like that? I have a set of single arcs and a set of double arcs. So for a parallelogram, I'm guessing that opposite angles are congruent. Very good. What is this picture trying to show? We already said opposite angles are congruent. So what is that picture showing? Okay, Graham is saying that the angles of a quadrilateral add up to 360, and I agree with you. But that's a property for all quads. That's not a property specific, unique to a parallelogram. Oh, Rishi, you're saying something about half. I didn't mean to make those half and half. I meant something else. So we know that this is parallel, right? This is parallel to this. Do y'all remember one side adds up to 180? That's a good guess, but we wouldn't want to say sides. Angles next to each other equal 180. Good. They don't equal 180, but they sum to 180. Same side interior angles are supplementary. So we're going to talk more about that one later. The official property is consecutive angles are supplementary, but we'll talk about that later. And what do you think this last one is showing us? What do you think that last one is demonstrating? Not that the diagonals are congruent, because in the warm-up we learned that that's just not true. Good, Chloe. The diagonals bisect each other. So if this is congruent to this, then that means that's a midpoint. So that means that segment got cut in half, and so did the other one as well. Very good. Okay, so the definition of a parallelogram is a quadrilateral with both pairs of opposite sides parallel. That's also property number 1. That's property number 1 on your family tree. So go to your family tree, and where it says number 1, you can just write opposite sides are parallel. Property number 1 on your family tree. Opposite sides are parallel. What does parallel mean numerically? How would I check with numbers that two sides are parallel? Oh, Chloe was saying if the alternate interior angles were congruent, we would know it's parallel. Okay. I was thinking more on the lines of slope. If I knew the slopes of the lines. Right. So parallel lines have the same slope. So if I was trying to check to see if this was a parallelogram, I would need to find the slopes of the sides, and the slopes would tell me whether the lines were parallel or not. Property number 2, write it on your family tree. Opposite sides are congruent. Got it? Opposite sides are congruent, the same length. Property number 3, opposite angles are congruent. Got it? Property number 4, this was the one that was kind of hard to put into words. This technically, how we say this property in this class is consecutive angles are supplementary. And we'll talk more about that in a minute. Consecutive angles are supplementary. Write it down. Consecutive angles are the angles that share a side. So you see how 60 and 120, they're sharing this side. This 120 and this 60 are sharing this side. Whereas angle 60 and angle 60, those don't share a side. Those are opposite. So consecutive is like whichever angles are not opposite. Another way to look at this, y'all brought up, was a great point. Let me get my handy dandy highlighter out. Or we'll do crayon. That's more fun. If these are parallel, and this is a transversal, then these two angles are same side interior. And same side interior starts with an S. And anything during that unit that started with an S was supplementary. So those are supplementary because they're same side interior angles. So that's another way to think about property number 4. Consecutive angles are supplementary because they're same side interior. And the last property on the list, number 5, numero 5, the diagonals bisect each other. They cut each other in half. The diagonals are not congruent though. Be careful because the diagonals are not the same length. One is longer than the other. Okay. So, if quadrilateral ABCD is a parallelogram, what do you know about triangle ABD and triangle CDB? Mark your picture. I'm going to give you a minute to sketch this picture down and just mark everything you can about those two triangles. Maybe try to prove them guilty of being congruent and find out why they're congruent. Side, angle, side, angle, side. Mark your picture. I'll give you a minute. Oh, good. So I'm guessing you marked things like a shared side. Maybe you put a tick mark on BD because it was a shared side. Now we know opposite angles are congruent. So maybe you put an arc here and an arc here. Maybe then you went to, oh yeah, opposite sides are congruent. So maybe you put tick mark there and tick mark there. Well, right now this would spell the bad word, angle, side, side. So we wouldn't have enough. But, oh yeah, I forgot. These opposite sides are congruent as well. So I didn't really need that angle at all. Those two triangles, triangle number 1 and triangle number 2, are guilty of being congruent by side, 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 or side, angle, side. It depends on how you approach the problem. So when you draw a diagonal of a parallelogram, you get two congruent triangles. That's good news because once you find a measurement in one of the triangles, you've really found two measurements. So you do the work once and it pays off twice. This is not one of the properties. Notice it doesn't say 1, 2, 3, 4, or 5. It's just like a bonus, like, hey, this is cool, this is true. The diagonals divide the parallelogram into two congruent triangles. How did I know BC and AD were congruent? Because, Johan, one of the properties was opposite sides are congruent. That was property number 2. Okay, from here on out, we just are going to work examples. Edge rule, there's 5 properties. 5. So, write this down in your notes or draw a picture somewhere on scratch paper. Given quadrilateral ABCD, AD is 6x minus 3, AB is 5x, BC is 4x plus 17. Find the perimeter. Okay, so if we label our picture, first of all, this is very important. When you label a quadrilateral, you need to label it circularly. That's probably not a word. You can go clockwise, you can go counterclockwise. I don't care which way you go, but you can never jump across your shape when you are labeling it. So if I wanted to start here, I'm just going to start somewhere you probably didn't start just to show you. Then you would need to go around in a circle. A, B, C, D. I can't jump across my figure. I have to end back like where I started. Okay? AD is 6x minus 3. AB is... So what is step 1 to this problem? What is step 1? So every time you do something in this unit, I want you to have a property to back it up. So they said find x. And then Chloe said opposite sides are congruent. She is backing up the fact that she's going to go to the side of her paper and do 4x plus 17 equals 6x minus 3. She's not just doing that because she feels like it. She's doing it because there's a property on her family tree that says she's allowed to do it. So then we solve for x, and what do we get for x? So you solve and you get x is 10, and then you simply plug it back in. What do we have? 57? When you know one side, you really know two sides because opposite sides are congruent. And so then we'd have 50. When you know one side, you know the opposite side is congruent. And so what's the final answer? The perimeter. Yep, 214. Let's move on. Okay, good. Good. All right, how would we start this problem? I'm sorry, I'm insulting your intelligence. We're going to set them equal. And the reason we're going to set them equal is because opposite angles are congruent. We have a reason. We can back up what we're doing, so therefore we can do it. I purposely did not make the algebra too hard on these. What do we get for x? Hello? Good. All right, the measure of angle D would be what? 20? 6 times 5 is 30. 30 minus 10. So we know these two angles. When you know one angle, you really know two angles. So the measure of angle D is 20, and what is the measure of angle A? You have to have a reason for it. You guys said that the measure of angle A is 160, and make sure you can always back it up. Not prove it, but, back up your work. Consecutive angles are supplementary. That's what makes angle A 160 and angle C 160. Because consecutive angles are supplementary. Same side interior. Johann, not alternate interior. It's same side interior angles. Find each missing angle in the parallelogram. So draw that parallelogram on your page and find every single angle that exists in that parallelogram. Go. So because this is a parallelogram and we have those parallel sides, we get to keep using those theorems from last semester. And one of you was mentioning over and over the alternate interior angles, and that is true. Those exist too. When you look at two parallel sides and one diagonal, you have alternate interior angles. And then you have another set of alternate interior angles. So you're going to use those a lot in a parallelogram when a diagonal is drawn. Alternate interior angles are congruent. They're not supplementary. So we can literally just take that 18 and we can put it here, 18. We can take the 25, we can put it here, 25. We can take the 88 and we can put it here, 88. Now where do we go? We have that one angle left. Now, someone might argue that we could add up all those numbers, subtract it from 360, and divide by 2, right? That's one way we could do it. Or we could look at triangles. Good. Triangle AD blank because you can't name the middle. Yeah. Even though we're in the quadrilateral unit, we're still going to use triangles like crazy. So yes, look at that triangle, 88 plus 25, and subtract it from 180. Very good. What do you get? Yes, yeah. Then vertical angles after that. So this is 67, 67. And then we could do linear pair from there, right? 113, 113. And then we could look at triangles again. Look at this triangle. 180 minus 113 minus 18. And get 49. Let me offer another way we could have gotten the 49. Let me offer another way we could have gotten the 49. What's angle D in total? What's angle D? 25 plus 18. This angle is 43. We know that consecutive angles are supplementary. So 180 minus 43, we know angle A is 137. So we could have just subtracted 88 from 137 using consecutive angles are supplementary. So that's up to you how you do that. Okay, let's keep going. Okay, next example. DCB is double the measure of CBA. Find the measure of BAD. Ooh, this is a good K-level problem. We know when we have a ratio of angles or a ratio of sides, it helps to use the letter x, to use a variable to help us represent them. So if I call angle CBA, this whole angle, if I call it x, then angle DCB is 2x. Does that make sense? If I call CBA x, then I can call this one 2x. And what's the relationship of angle B and angle C? What's their relationship? Are they congruent? No. What are they? Consecutive angles are, hope you're typing it, supplementary. Good. They sum to 180. So I would say that angle C plus angle B equals 180. Very good. Find the measure of angle BAD. Okay, well I know if I find angle C, which way do I do it for you? If I find angle C, then I've really found angle A because they are congruent. So angle C is 120, therefore this one is 120. Yay! All right, go ahead and try this one. You're going to be working with angles, again, not with sides. They did tell us that it's a parallelogram, and they want you to solve for x and y. What would y'all start with? What would y'all do first? I agree. Solve for y first, because you can use alternate interior angles. I think that was a typo, but yes, you're right. Alternate interior angles, 6y plus 5 equals 35. 6y equals 30. Boom, we have y. Yep. All right, so we know that this angle is 35 because it's alternate interior. There's multiple ways that we could do this. I bet a lot of you are doing this. Are you doing this? Are you looking at this triangle right here? Because you can look at that triangle to find x, or you could do consecutive angles or supplementary. And you could say, oh, well, angle A is 80, so angle D is 100, and you could work with it that way. So it's totally up to you, okay? What are we getting for x? 13. Okay, good. Are there any questions about the two different ways I showed that you could get x? Could use consecutive angles or supplementary, or you could use the angles of a triangle add up to 180. Same thing either way. Same operation either way. Yay! That is all. The only thing I'm going to say as I close this lesson is that you are about to collect a lot of properties. Do you see how many properties are on that family tree? There's a lot. And so you are also going to have to memorize these. You're not going to get to use your family tree on your quizzes or your test. So I would recommend that you start memorizing these. Sometimes it's helpful to make up like little hand signs or things to remember them. And I'm going to go over those with you tomorrow. I'll go over the hand signals and we'll do them every day whether you want to or not. But please begin looking at the properties and committing those to memory. That way you're not memorizing all of them the night before the test. Okay,